Just want to give you a quick tour of how to prepare for your Unit 3 test coming up this Friday and go over this outline and also skim over a few topics that you want to focus on as you prep. So if you follow the audio file posted in this news post, if you open this audio file, you'll have an explanation of the chart itself and what to focus on. So I'm not going to repeat what's already there. Make sure to check that out. A reminder that you can click on these links to get into each topic, and I'm going to give you a quick tour of these topics. You'll notice that if we're trying to prioritize our time and we look at the total on each topic, there's a lot of emphasis on Activity 2, Fossils and Mass Extinctions, quite a bit on Absolute Dating, Activity 4, and lastly quite a bit on Paleoclimate, Activity 6. So let's take a quick tour through some of those topics. So if we look at fossil evidence. When we look through this section, it's going to go through with you what we can figure out from fossil evidence, and that is a key thing to take away, to look through what are the key points that we can garner from fossil evidence. You do want to know the basic types of fossils, so original remains, casts and molds, carbonization, permineralization, and trace fossils. So make sure to read through that material to get a sense. You can try these two interactive activities. This BBC Fossils link takes you to some videos that are a really nice summary of different fossil evidence. And then if you go to the exploration of fossils, there's a very simple animation, quite basic, but also explains really well how different fossils form. As you go to the next page of the fossils section, you're going to see some information on mass extinctions. If you follow these color codes along the top of this graph, it's trying to show you different periods, epochs in our Earth's history. If you look at the blue lines in this graph, it explains where we had a lot of different species or fraction of genera that are present. So how many living things did we have? So if there's a peak in this graph, it tells us there was a lot of living things. If there's a huge dip in this graph, it shows us there was very few living things. So if we look at the Cretaceous period, we see a huge dip, and that if you look at 65 million years ago, you can see that we see that huge dip at the end of the age of the dinosaurs. Also, at the end of the Permian period, we see a huge crash right at around 250 million years ago. This was by far the largest extinction event that ever happened, when 95% of the ocean organisms disappeared. The KT boundary is a term that we use to refer to the major extinction that happened at the end of the dinosaurs. And so that's between the K and the T period. And so it's talking about, in this paragraph, you want to understand what was the major cause of this extinction that's widely accepted by scientists. If you click on this activity from NOVA, it's going to give you a bit of background and activities to understand extinctions and all the topics that have been mentioned a little bit better. This is really not focused on in the test, but if you're looking for a little more interesting extensions of extinction, you can watch this video to see how scientists have noticed a 26 million year pattern in extinctions, a very regular cycle that major extinctions happen on Earth. So you can watch this video to see their one theory that was proposed in 1980, but this is not a focus on your test, just to keep in mind. Make sure as you study for the test to go through these check your understanding questions that are at the end of each section. And these ones are good because they ask you to look at what fossil life tells us, what types of fossils are, and what fossils teach us about the past. Moving into absolute dating, because that's where we see a lot of focus as well. You want to go through this section, and in the very intro, you want to understand how we use radioactive samples to tell us the dating, and how is this better than relative dating that we looked at in the quiz. It goes through a basic introduction to atomic structure, so how are atoms, what are atoms composed of, and then how do they decay? So how do radioactive isotopes break up over time? So three kinds of decay: alpha, beta, and electron capture, and what happens in each of those processes. You're not going to see tons of detail on these exact kinds of decay, but you do want to understand the four isotopes that are used to date different samples with absolute dating. It goes into talk about carbon-14 specifically, a really radioactive isotope of carbon that's in every living thing, and you can use this to help you understand the date of once living things. The limitation of carbon, you want to keep an eye on this, is that carbon 14's half-life, or how long does it take for that atom to break up? What is the period of time that it takes for half of that sample to break up, is only 5,730 years. So carbon 14 isotopes can only be used to date samples from 100 to 70,000 years old. When we get into rock samples, we can use other isotopes, including uranium, potassium, and rubidium. Each of these isotopes has a specific use based on the kinds of rocks that you would find it in, and also the age of that isotope, so the half-life, or how long that isotope sticks around. So we know that uranium is not common in igneous rocks. You don't need to get into too much detail about different types of rocks, but just note that it can only be used in specific kinds of rocks that have a lot of uranium in them. It also is good at dating things that are anywhere between 10 million and 4.6 billion years old. So it can take us all the way back to the beginning of the solar system. Potassium in feldspar and mica, it's found in igneous rocks. It has a date range of 50,000 to 4.6 billion years. So potassium is really versatile, spans a long range of time, taking us from the end of that carbon 14's limitation all the way to the beginning of the solar system. So really useful isotope. Rubidium is another isotope that we can find that helps us date igneous rocks as well. The only limitation with rubidium is that it has a really long half-life, and so it can only date samples that are extremely old, anywhere from 10 million to 4.6 billion years. Make sure you've watched this video with Bill Nye. It talks a little bit about everything. It doesn't just talk about absolute dating, it talks about relative dating, talks about how we use isotopes, and it also gives you a little bit of background on geologic timeline, about how long each of the periods of Earth's history were. Again, make sure to try these questions. These are really similar to the kinds of questions that you might see on your test. The other major section that you want to make sure that you study that has quite a few marks for your test is paleoclimate. As we've gone through various tutorials, we found out that some people have climate background from grade 10 science. Everyone should have it from grade 9 geography, but not everyone spent a great deal of time on it on grade 10 science. So know what your experience was in grade 10 science, and not only that, what do you remember, and decide how much time you want to spend on this section. Paleoclimatology is the study of past climates, and that's what this focuses on. So first it gets into how do we figure out the climate of really old times in Earth's history. So it goes through how we use ice cores, and what do ice cores tell us about the gases in the atmosphere and the pollen that was floating around in the air, what it tells us about different kinds of plants that existed. It can date back to samples over 800,000 years old because the ice layers in the Antarctic, that permanent ice, is just layered over years and years and years. And so if we dig down really deep into the ice, we can get really old ice telling us of really old past climates. Dendroclimatology is a fancy name for just looking at tree rings like you see in the picture. Tree rings, each growth season is a ring, and whether that ring is wide or small tells us about how that growth season was. It doesn't tell us very much in terms of age. It only goes back about 4,000 years because it's the age of the tree. Fossils and living organisms, for instance, coral rings, and other fossils can tell us a lot about the conditions based on how many of the fossils there were and their condition. They can tell us about the state of the ocean, whether it was acidic, whether it was really hospitable, or whether there weren't that many organisms surviving, and that's what we can get from that. There's an activity here that you want to go, it just suggests that you go back to activity 1 and think about the geologic timeline before you jump in to look at what the climate was like in each of the epochs or eons. It describes for you how the climate was in Precambrian, how we had a very inhospitable climate, really hard for organisms to survive, for life to survive, because we had a lot of dust and debris and a really thick carbon dioxide atmosphere, as well as sulfur dioxide from a lot of volcanoes, causing acid rain to fall all over the place. The end of this period of time in Earth's history is associated with a complete freeze of the entire Earth, a huge ice age. The Paleozoic climate, which is the first era of the Phanerozoic eon, lasted from about 430 million years ago and lasted a few million years. The year again was an ice sheet or an ice age that covered a lot of North America at the end of that period. Mesozoic is the age of the dinosaurs, and this climate was pretty warm compared to today. There wasn't really any evidence of glaciation in the middle of the age of the dinosaurs in the Mesozoic era. The climate was the climate warmed a lot during that period and then gradually cooled off towards the end. And then we know from the previous section on extinctions that there's a dramatic cooling at the end, possibly the result of an asteroid impact that would throw up tons of dust and debris, blocking the sun's energy and cooling the planet. Then we have our most current era, the Cenozoic era, that's gone through periods of warming and cooling over the past few million years. For ice ages and warming periods and glaciation, those have happened in cyclical times throughout this entire era. To go into those cycles, you get into the second section here, which goes into Milankovitch cycles. You do want to understand, and it kind of ties back into Unit 2 when we looked at the motion of the Earth and the solar system around the Sun. We know that the Earth points towards the Sun at a tilt. So it has a tilt. It doesn't rotate completely perpendicular, but at a tilt. And that tilt, and we know it's a certain distance, and we know that it orbits around the Sun. So it rotates and orbits around the Sun. So how do these motions of the Earth affect Earth's climate? We can look, you can open this interactive, so make sure that you do this activity to understand this better. And then there's a summary here of some of the data used to understand Milankovitch cycles. So there's a bit of a cycle in the glacier periods that we've had, or the ice ages that we've had. We can see that we had warming and cooling in a regular pattern. We can compare that to the wobble of Earth's orbit, the movement of Earth around the Sun, and so we can use those different factors of Earth's motion and compare it to glaciation. And you tell me, do you think there's a pattern? Make sure to do this interactive activity though, because it's going to walk you through the answer to that question. Lastly, you're going to want to look at the unit test page itself, which gives you a nice list of terms. Make sure you know how to define all of these terms. But going back to our activity, our unit test overview in the news, there's one little link to a flashcard set. You can see a Hungry-Bug version of this below. But if you go into StudyStack, I just searched geologic history and found this stack, which has a lot of terms from our unit. You can either click through the cards and use them to quiz yourself, so you click on the topic and then you flip it by clicking it. You can also play games like Hangman, where it gives you a clue and you have to guess based on the terms from the unit, and then play Hangman. You can play Hungry-Bug as you saw before. You can use a table where you're just matching the terms to themselves, so you can try and recall what this term would be and then click to reveal the term. But there's lots of interactive games. You can also go into StudyStack and just search if you want to go into more detailed information on some of our topics like mass extinctions or fossils. A lot of people have put together lots of different study stacks, and you can click through these and see if any of them seem related to our material. Okay, so good luck studying, guys. Make sure to email me if you have any questions that aren't answered by this video, by this summary chart. And again, don't forget to listen to that audio file giving you tips on how to study.